Good morning, everyone. This is Carl Griffith, Director of Emerging Technologies at Graybar, and I would like to welcome you to our Graybar G2 Talk presentation today, the title of which is Why Base-8 in the Data Center. This talk is part of our normal monthly G2 Talk webinar series, and we're just so delighted that you've joined us today. Before we get started, though, I'd like to give you a little bit of information about Graybar. We help our customers power, network, and secure their facilities with speed, intelligence, and efficiency. Today, those facilities will be data centers, and we're going to talk a lot about networks and about speed and intelligence and efficiency inside the network, inside the data center. If you're one of the first 50 people to be online with us today and then stay to the end, you're going to get a certificate for a cup of coffee from Graybar. So look for your email later today, and you'll see a coupon in there, and you can exchange that coupon that you'll print on your PC printer and take it to a national coffee chain, and you can exchange it for a cup of coffee. On the bottom of your screen, you will see a Q&A box, and this presentation will have a question and answer period in there. As we go through the presentation, please hit that button and type your question in the dialog box, and we'll see it at this end. And then when we get to the Q&A time, we'll go over your questions. This presentation today is worth a Bixby credit. So if you stay online for the entire presentation, at the end you can download your Bixby certificate right from the Graybar G2 Talk webinar platform. So just click on the ribbon icon. You'll see it looks like a little blue ribbon at the bottom of your screen. At the end of the presentation, you can click that and you'll get your certificate. It'll be delivered directly to you. Lastly, all of our presentations are archived. So we've been doing G2 Talk webinars for several years now, and if you want to go back and look at some of them, you can do that. Just go to the G2 Talk webinar on or G2 Talk logo on graybar.com, click that logo, and there'll be a link to the archive, and then you can download the presentation. This presentation today is going to be very valuable to you, I hope, and you may want to share it with your colleagues and other folks in the industry, and we encourage you to do that. Today we're happy to team up with Corning. And as a data communications distributor, Graybar works alongside Corning every day to ensure that you have the coverage and the connections that you need to meet the demands for rising data center capacity. You can visit graybar.com and learn more about the Graybar solutions at graybar.com. At this time, I'm happy to present to you our speaker today, and that would be Dave Hessong. And Dave is the manager of global data center market development for Corning. Dave graduated from North Carolina State University, and he has a degree in chemical engineering. And he also received an MBA from the Kelley School of Business. During his career with Corning, he's had several positions as a process engineer, as a private network systems engineer. He's been a senior application engineer for multimode fiber and flame retardant cable, the manager of private networks, and his experience just goes on and on and on. He's a subject matter expert when it comes to parallel optics and the use of optical communications inside the data center. Dave has published several industry articles and contributed to several IWCS papers. He served as the chairman of the ICEA 596 standard for indoor cable rewrite. Dave teaches numerous classes and webinars on data centers and systems design throughout the United States and Canada. So without any further delay, I'd like to present to you today David Hessong to talk to us about Base-8 inside the data center. Welcome, Dave.
Thank you, Carl, and thank you to Graybar for allowing us to come share in some of their G2 talks and present what I hope is a pretty interesting story. Now, I'm not sure how often St. Patrick's Day and the start of the NCAA tournament start on the same day. But I think there's no better way to celebrate that monumentous event than let's learn about structured cabling and the future of that structured cabling in the data center. A real quick agenda. We'll talk a little bit about Corning and some key differentiators, in the way to help set the stage of what we do to try to predict the direction of the market, and try to predict future needs of the market, and how that could potentially play out into products. We'll talk a little bit about solution development and our methodology to doing that. We'll talk about how that played out when we released the EDGE platform in 2009. Then we'll talk about the technology roadmap, what the landscape of the world looks like today, and what the landscape of the technology world looks like, going forward for the next 5 to 10 years. That technology roadmap will lead us into Base-8, and we'll talk about some of the Base-8 advantages in the data center. And finally, if time permits, we'll translate how those advantages are basically translated into products that you can use and install and take advantages of all of the things, of all the value props out there. And of course, we'll leave at least 10 minutes at the end for Q&A. So the first thing we'll talk about a little bit are some key differentiators. So of course, everyone knows, or most people are familiar, Corning sort of developed the commercial optical fiber and, deployed it in the early 80s, across the continent. But we also were one of the first to deploy MTP technology. And we actually started this in the early 90s, private labeling some product for a large integrator. But it's hard to believe that almost 20 years ago, we released the plug-and-play system, so a fully pre-terminated MTP solution to change the way people cabled the data center. And then in 2009, the game was changed a little again with the advent of bend-optimized fiber, so fiber that you could bend, multi-mode fiber you could bend and exhibit no bending loss. As a result of that key fiber development, and a lot of voice of customer, we were able to kind of change the landscape of how data centers are deployed with our EDGE platform. And so now you had a platform where you could pack things in there extremely tight, and you didn't have to worry about fiber bending affecting performance. One of the key things we do to try to be able to predict the future of what technology looks like and translate that into product needs is work with a lot of technology vendor partners. We spend a lot of time and money establishing relationships with all the large switch and transceiver manufacturers, sharing of roadmaps. We help them qualify a lot of their products before they ever hit the market. So it's a very mutually beneficial relationship because, we get to understand their roadmaps and where the technology is going and adjust our products accordingly. But we can provide them all the technical expertise of what kind of claims you can make about these products on installed infrastructure bases and things like that. You'll see a lot of this play out, and I'm not going to talk about, for anyone who's attending the OFC conference next week in Los Angeles, you'll see a lot of joint development efforts between Corning and a lot of the people on this slide to present kind of technology that's going to be released in the next couple years and what it's capable of. We also spend a lot of time in standards leadership. We participate in all the major standards. And historically, just playing in the standards would give you a pretty good indication of the future. And interesting things happen in the past couple years, and it's that a lot of the technology is hitting the market ahead of the standards or outside of the standards. And that's really why a lot of companies, including Corning, you put a lot more emphasis on these technology vendor relationships. And you can really see that play out. I always say that the prime example of how the market has shifted is, when Cisco released their bidirectional transceiver, that was outside of the standards, but it was very widely accepted across all different kinds of end users, right? It wasn't, enterprise people weren't saying we need to wait for it to be standards compliant or financial people. There's been an acceptance that you can have very acceptable market solutions outside of the standard, which is why it's key to pay attention to both the technology guys and the standards. So let's talk a little bit about our job to develop. We really want to focus on what drives solution development for the data center. And what we really focus on is to improve the total cost of ownership throughout the life of the infrastructure. You know, our customers are typically asking us to give them an infrastructure that lasts at least 3 generations of electronics. And depending on that churn rate, that's anywhere from 10 to 15 years. So a lot of things we do before we try to release a new solution is we try to understand the migration path to all new technologies and even topologies. So going from a 3-tier architecture to a 2-tier spine and leaf architecture, what does that do to the end user needs, and how does that translate into product features? You know, migration path to higher data rates. Like we said, we have to typically withstand 3 generations of electronic upgrades. That's our goal. And that typically means you have to go through at least the current technology speed and then the 2 generations of protocol speed beyond that. And how do you handle that? Obviously, system equipment advances. What we do plugs directly into other people's products, in particular a transceiver. So we have to understand their roadmap, their requirements, their specs, and their needs before we release any new solution. And of course, in our industry, everything basically boils down to cost. If you follow the history of everything that's been successful in this space, it's really just following the economic equation of what became the most cost-effective way to deploy a link. We pay attention to standards and regulation, and of course, we also pay attention to how usable is the solution once it's released into production. So when we started in 2009, before we released EDGE, we did this multi-year effort to understand everything in the market. And at the time, end users and installers gave a lot of feedback on the usability of or on the product features themselves. And if you follow the history of, you know, kind of the data center solutions that were in the market at the time, they were basically all modified versions of the hardware that was used in the local area network. That hardware was established. So when it came time for people to be introduced to pre-terminated MTP systems, you basically made modifications to the existing local area network hardware and then added MTP modules and trunks. So when we went out, it was essentially, if you could start a data center solution from scratch, what problems would you try to solve? And you heard things like increased density, you know, faster deployment, better polarity management, you know, scalability, cost effectiveness, usability. You know, there's things that could be done here if you basically were willing to design a solution from scratch. So what really resulted was we basically challenged the engineers to say, hey, end users and installers, end users clearly want more densities, installers clearly want more usability and faster deployments. So what really happened was with EDGE, it became a thing of how do you make density usable. So we basically doubled the density of a housing to 576 fibers in a 4U, but once you double the density of the housing, you basically had to make it usable, and you basically created density bottlenecks all throughout the system. So one of the big things that allowed that equation to change was the advent of sliding trays. So now you could slide trays out, so now all the connectors didn't have to exist in one access. And it essentially gave you unlimited finger access. But now you created another problem of you have twice the amount of jumpers per housing, and how do you route them, right? So you came to a connector that was a uniboot jumper, which had a one trigger and a cable that was half the size, right? So you had to follow that density story throughout the entire solution. You know, smaller trunks so you could fit more in a cable tray. Well, the other problem that continuously comes up and still continuously comes up in the industry is the more stuff you put in a box, the more complex labeling becomes. And that was all part of usability. So one of the things we did with EDGE was, hey, replicate the patch field in a very clear label so I always know where the MTP in the back of the module is going. And the other part that was critical for EDGE, which kind of changed how people could label, is once you got to EDGE, the tray was always the same, in the same orientation, regardless whether it was a 1U, 2U, or a 4U housing. That became convenient because you could use a unified labeling system throughout your entire data center. So we felt good. We released it in 2009 to huge success into the market. So fast forwarding, of course, you know, when you do something good, you get asked to do it again. And they really came back and said, hey, we're going to challenge you guys again to go find out, you know, EDGE is 6 years old. Is there a new solution is there new needs on the market that a solution can solve? And we set out on this big thing, and we got a lot of feedback from end users and installers, and they were actually pretty happy with the hardware that was on the market. You know, they liked the density, they liked the usability. But what we really got is we asked, well, what does the future of your network look like? We got a lot of confused looks back and saying, we're hearing a lot of different things in the industry, and we ourselves are actually confused, and we were kind of looking to you guys to provide some clarity. So we realized very quickly that maybe this time around, it wasn't about getting exclusively, you know, voice of customer about end users and installers. We needed to go out and set on this year-long effort to figure out where technology was going, because people were struggling to understand it all, and a lot of our customers who are infrastructure managers are basically getting tasked to build an infrastructure that's going to withstand 3 generations of electronics, and they don't understand what those electronics are going to look like. So what we really did was set out, and it really became, at first it seemed overwhelming because there's an alphabet soup. So at the time, Ethernet was talking about 40, 100, and 400 gigabit Ethernet. You know, and since that time, Ethernet's talked about 25, 50, and 200 gigabit Ethernet. So there's even more flavors that you try to understand, right? Fibre channel was talking 32, 64, and 128. There was multiple duplex solutions on the market. There was multiple parallel solutions on the market. And it seemed overwhelming until you really started to study the roadmap and realized that all the solutions on the market at some point ended at both 2 fiber and 8 fiber. There might be stops along the way, but at the end of the day, a solution that was optimized to handle 2 and 8 fiber, you know, would be something that the customer desired. So a quick sampling of the people we talked to, like we said before, really just all the large switch and transceiver makers globally we interviewed, and what's surprising is a lot of their roadmaps are actually quite similar. And what really turned out to be was you're coming to an interesting point in technology. So duplex serial would always win as the most cost-effective technology if there was a way to get there. So when you looked at what won long-term 1 gig, it was a 1 gig electrical trace driving a 1 gig optic. What won long-term at 10 gig was a 10 gig electrical trace off of a 10 gig switch ASIC driving a 10 gig optic. That ended up being the most cost-effective, even though there were other technologies along the way for 10 gigabit. But what became interesting is, hey, these speeds we're talking about, 40 and 100, you know, the technology on the market, the switch ASICs were 10 gig, and the VCSEL optics on the market were really capped commercially available like 26, 28 gig. So it wasn't a matter of figuring out how to turn something on faster, just turning the light on faster, you're going to have to do something to supplement that. And there's really 3 ways to do it. We'll mention all 3 and talk about 2. The first one is wave division multiplexing. And in wave division multiplexing, you still use 4 transmit sources. So there's 4 lasers for TX in each of the devices, and there's 4 receives in each of the devices. But you do some mux and demux to be able to send it out over 2 fibers. And I point that out because a lot of times people think there's only 2 fibers inside of WDM. It must inherently be more cost effective. In reality, a lot of times it's the opposite, because not only do you have the same amount of laser transceivers in there, you also have to add all this mux and demux capability into the transceiver. So think of WDM as taking 4 independent lasers or VCSELs, operating at 4 independent wavelengths, and then combining them over a single fiber. Hugely popular in the outside plant world. Been done for a long, long time. Relatively new to be introduced into the data center space. The other way to do it, and it's still going to take 4 lasers or 4 VCSELs, but we're going to operate them all at the same wavelength and just continue to send them out over 4 fibers. So some people call this spatial division multiplexing. So these transceivers, so for 40 gig or 100 gig on multimode, it was all operating at 850. And you take these 4 lasers and just send them out under 4 independent fibers. So you tended to make pretty cost-effective transceivers, but now you had a lot more cost into the cabling, and that's kind of why you had to pay out, how you had to play the economics out. So there is an additional one, multi-level encoding. Some people hear PAM4 is a pretty common one that people are talking about on the market. Tends to be a little bit costly at this point in time, and there is some power penalties associated with it. So it will make its way into the products, but it's not making its way right now into the first and second generation of the products. So of course we said the most economical solution is going to win long term. So we set out to understand the economics. Would one of these solutions go away and one not? And in talking to people, we found a pretty interesting dynamic. And like we said earlier, inherently, if you could do serial duplex, it would win long term. But what happened was, when I looked at 40 gig parallel, 10 gig components were extremely cheap at the time. So I could put a lot of 10 gig components in parallel and come out with a very cost-effective transceiver. If I was going to try to do that over 2 fibers, I had new sources operating at different wavelengths, and I had additional components that had to be introduced to combine those wavelengths over a single fiber. So parallel tended to be relatively cost-reduced when it was introduced to the market, while duplex tended to have a relatively steep cost curve. And when we started talking to people, some people, we got this out of a Microsoft presentation they gave at OFC a couple years ago. They basically said, hey, we always lead the way with speed deployments. When other people are deploying 40, we want to deploy 100. When other people are deploying 100, we want to deploy 400. And therefore, we've made the decision that if I install a parallel infrastructure, right, I will always be on that early part of that cost curve. And if at any point in time I ever want to convert to a duplex infrastructure, right, I can do that because I have the available fiber. And other people, depending on when they're going to install, arrive at different conclusions. And what really came out to say, and we'll see this when we look at the roadmaps, is these solutions continue to be introduced at every speed, both a parallel option and then eventually a duplex option. So what you really want as an infrastructure manager is the optionality for your network guy to choose what's most cost effective at that point in time. So you as the infrastructure guy had to deploy an infrastructure that was optimized for both parallel and duplex solutions, so there was no restrictions on what your network was capable of. Real quick, I want to show people this because it's going to help explain the next slide a little bit. When we talk parallel 8 fiber, which we're going to see all over the roadmaps, it really is a 12 fiber MTP with no fibers in the middle 4. That's the spacing they use, and that's the spacing that's used across the industry. So you have 4 transmit fibers on one side of the MTP, nothing in the middle 4, and then 4 receive fibers on the end of the MTP. Whether it's 4 by 10 for 40 gig or whether it's 4 by 25 for 400 gig or at some point 4 by 100 gig for 400 gig, that is the roadmap that all the parallel solutions are driving towards. So this is actually a pretty interesting slide to summarize a lot of the work that was done. So we went out there to understand the duplex and the parallel world and how it was played out. So the 40 gig world was being deployed when we did this. And you'll see, in the dominant way it was being deployed was in parallel. And then you started to see some 2 fiber solutions come on board. So when 40 gig was released, everything was a 10 gig electrical trace. 10 gig components were all over the market. People wanted a faster speed for their switching network because the servers were moving to 10 gig. So now the switch had to go to something faster. So it went to 40 gig, and they put 4 10 gig links in parallel. So that was SR4, and then there was some ESR4 to just extend the distance further if needed over multimode. Well, then something interesting happened, and Cisco, in conjunction with some of their transceiver partners, released this bidirectional transceiver. So now it was a relatively cost-effective way to deploy 40 gig over 2 fibers. And then you saw some competing technologies out there to do that. And people said, that's great. Well, what happens at 100 gig? Well, at the time, 40 and 100 gig was written as one standard. So they only had 10 gig traces. They only had 10 gig optics. How did they write the standard? SR10, so 10 lanes of 10 gigabit. Which sounds great until you realize that now you're required to bring up a 24 fiber MTP for every link you want to bring up. And you very quickly realize why it sounds great. I wish SR10 would have taken off as a fiber manufacturer. It never gained wide adoption in the industry because it was just so much fiber for that link, right? It wasn't super cost effective. If we're going to look at some adoption curves, SR10 really turns out to be a niche speed bump on the way to SR4, 4 by 25 gig, when it became popular. But at the same time, the 2 fiber guys are saying, we have paths to do 100 gig over 2 fibers. Cisco's openly talked about 100 gig bidirectional. And these we call SWDM guys. So these are the guys that are going to be pushing out wave division multiplexing around the 850 wavelength for 40 gig, also will have a solution for 100 gig. Right? So very clearly, when you had line of sight through 40 and 100 gig, the solution that won at the end, and we had visibility to it at the time, was 2 and 8 fiber. If you went down to single mode, you had the same thing. You had parallel single mode, which was relatively cost effective in the data center space. And then you had 2 fiber single mode. Historically, 2 fiber single mode was a 10-kilometer solution. It was not cost effective in the data center space. But people saw what was playing out in multimode and said, hey, we need something to potentially run longer than multimode, but it doesn't have to run 2 kilometers, right? I'm a hyperscale data center. I have length as long as 500 meters, say, and I need a single mode optic, but it's cost prohibitive to deploy the single mode optics on the market today. And what really came out with is all these people to develop 2 fiber single mode solutions with a range between 500 meters and 2 kilometers. So now that 2 fiber and 8 fiber story played out for single mode. But I really want to sit down and say, well, what happens at 400 gig? When 400 gig was being written into the standard, they had visibility to 25 gig switch ASICs and how all that would work. So the first generation, they wrote it was for 16 lanes of 25 gig. And what that really translated to was a 32 fiber MTP. So we went out and talked to all these guys and said, is a 32 fiber MTP going to be widely deployed? And the answer we most commonly got was, we're not going to repeat the lesson we learned with SR10, where we spent huge amounts of money to basically generate all these optics, only to not get any volume until it went to an 8 fiber solution, right? In the electronics industry, volume kind of cures all the ills of the cost of scaling up. So then people said, well, with multi-level encoding, I know how to take a 25 gig signal to a 50 gig signal. So SR8, people started talking about 16 fiber MTPs, which, potentially some will be deployed. But at the end of the day, when you really start talking to them, they believed that enough people are going to figure out how to do 100 gig cost effectively on 2 fibers. The way 400 gig will be widely deployed will be an SR4 solution where they take these learnings from 2 fiber 100 gig, put them in parallel over 4 fibers, and that's how you get 400 gig. Right? So all of a sudden now at 400 gig, the 2 and the 8 fiber story played out again for multimode. So when we went back and looked and went back and talked to the single mode guys, and lo and behold, the same story played out again. So then we kind of looked at the lessons history could teach us to say, how is this going to play out in the market? I think this one's pretty interesting because you go back through 2010, this is light counting data, through 2015, so it's actual data, and you really see, one, and that the economics still hold. If you can deploy multimode based on your distances, for most people, that's still the most economical way. So you're going to see multimode dominate the volume. But you really can see the transceiver cost curve playing out here, where parallel comes out, it's cost advantage at the transceiver, and over time, duplex follows down that cost curve, and you start to see parallel and duplex start to converge. Now, the thing about these volumes starting to converge is a lot of the people, by 2017, 2018 are on 100 gig, and by 2020 or 2021 might be on the 400 gig. Right? So then we wanted to see how 100 gig was going to play out, and there's not as much of a historical volume, of course, because 100 gig is really starting to get deployed now with the advent of the 25 gig ASIC. But here's the lesson a lot of the transceiver guys taught us. 100 gig with 20 fibers in and out started as a niche, and it never really became mainstream. It always kind of stayed in lower volume. Meanwhile, as soon as an 8 fiber solution was available, you see a very rapid adoption curve, right? And that's all being played out today with all the transceiver makers and all the switch companies now offering 100 gig SR4 8 fiber optics over multimode. So really, if you want to predict the amount of lanes, in a switch, everything is driven, and so you understand the ecosystem, you tend to want the optics to run at the same speed you're switching, right? So you have a switch ASIC. Today's technology, you have an electrical trace to the front of a pluggable optic. Well, historically, and this is Broadcom's roadmap, historically we had 10 gig switching. Well, when you had 10 gig switching, 10 gig optics and 40 gig optics, made the most sense. But what happened now that you could do 25 gig switching, right? With the advent of the Tomahawk, which are shipping now, does 40 gig make a lot of sense when you're switching 25 gig lanes? No, which is now you start hearing speeds like 25, 50, 100 gig, but now as a flavor of a 4x25, 200 gig, those kind of speeds. And what's really happening is the optics have got to the point where they could handle it, and the switch ASICs have basically come up to where everyone's going to do it. So now, the world going forward, you basically have a 10 gig ecosystem and you have a 25 gig ecosystem, and they're both very well established and will continue to be deployed. But for these people that want to do 100 gig in these new deployments, right, they're all switching to this 25 gig ecosystem. And that will continue to play out. Of course, we've talked a lot about Ethernet, and that's typically half of our network, so we want to understand fiber channel and what the big fiber channel players were doing. And lo and behold, what you found out in fiber channel was they were sort of going down the same path, right? Fiber channel always has been a serial solution. When you saw it 32 gig, it was a single two-fiber solution with a single line rate. But now, to not get outdone by Ethernet, right on the heels of 32 gig fiber channel, they released 128 gig fiber channel, which is an 8-fiber parallel variant, right? So they're keeping up to the speed roadmap of Ethernet. And then you actually see, you actually see a slower speed come out for 64 gig fiber channel. So most likely you're going to get there with some kind of multi-level encoding, but you're going to send a solution out over 2 fibers. Well, as soon as you release that to keep up in the speed race, you release a parallel solution for 4 by 56 gig. So we thought, okay, we think we understand it. All the solutions on the market are going to be 2 and 8 fiber. We really set out to not only understand the best way to deploy a solution that's flexible to do that, but to make sure we really understood the economics of why people were making the decisions they were doing. So we're going to talk about Base-8 advantages, the total cost of ownership, and we're going to talk about some of the analysis Corning did and why we invested so heavily in an 8-fiber-based solution for the data center as opposed to the 12-fiber-based solution that's dominated for so long. Just like 10 and 25 gig switch ASICs will continue to play in the market, 12-fiber and 8-fiber solutions will continue to exist in the market going forward. 12-fiber has a massive installed base, but for people doing extensions to their current network or new builds, we think there's a pretty compelling case from the customers we've worked with to evaluate an 8-fiber infrastructure. So real quick, we want to understand the total cost of ownership for both cabling and optics over time. So we basically put bill of materials together for 2-fiber multimode, an 8-fiber multimode, and 2-fiber single mode, and 8-fiber single mode to determine what was going to happen. And here's the result, right? So if you just look at the infrastructure, so if you just look at the cabling, right, you would make the decision that single mode's always more cost effective, right? Because single mode cabling, especially the fiber on a per foot basis, tends to be more cost effective. And we talked to a lot of people and they're like, I don't think I can ever afford duplex or parallel multimode. It's just too expensive. And you basically say, hey, you need to talk to the networking guys and get the cost of the optics deployment, right? If you look at it just on the infrastructure, you're only getting half the story. So you can see when you go just to the infrastructure story, of course, multimode's a little bit more than single mode and parallel's more than duplex. Well, at that point, you really have to say, okay, let's add in the optics and the patch cords. And what's interesting, at 40 gig, you're going to see parallel multimode is right off and out of the gate was the most cost effective, but it wasn't a huge difference between duplex multimode, and then you still had the separation where single mode was more expensive, which of course leads to the equation. If you can use multimode, meaning your distances are typically less than 100 meters, that's still typically the most economical choice for you to choose. So we said that's compelling, but I could see how people could do this analysis and get different things. So then we said, hey, the great thing about spending the money on infrastructure is your infrastructure is reusable. So you need to say, hey, my infrastructure is a one-time cost, my optics are something I have to constantly rebuy, right? Optics don't, right? When you go from 1 gig to 10 gig, you don't reuse your optic. When you went from 10 to 40, you couldn't reuse your optic. You could reuse your cabling. You couldn't reuse the optic. You had to basically remove those optics and those switch cards and put new optics in. And when you started to do this analysis across multi-generations of optics, what you really saw was multimode parallel looked really good. Duplex multimode looked pretty good, except you were never sure where on the cost curve you were going to be deploying the transceivers. So again, it pointed you back to, I need optionality between duplex and parallel solutions. And then you go over to single mode solutions, which don't look really cost effective today, but I will tell you there is a massive push in the market to cost reduce, and not just cost reduce the requirements on single mode optics. So they're actually designed to work in a data center environment. There's a lot of different companies evaluating it. There's currently 4 different multi-source agreements trying to win this race for this 500 meter to 2 kilometer optic for the data center. There's 3 different duplex versions and there's 1 parallel version. And we're all kind of sitting back and watching how that will play out. Now, none of the modeling shows it becoming more effective than multimode at short lengths, but these hyperscale guys who really are pushing the distances past multimode are really pushing the industry to develop more cost-effective data center-focused single-mode solutions. So the next thing we really try to understand is that I get parallel seems to be pretty compelling, but we keep talking to people who say, I'm deploying parallel transceivers, but I'm breaking them out into 10 gig networks. So we're like, well, why would you do that? And it really turned out, again, if you follow the dollar signs and the math, 10 gig transceivers we talked, or 40 gig transceivers as we talked, were essentially just a series of 10 gig links in parallel. Well, in the software, you could operate those independent channels as 4 10 gig signals, which essentially meant you could take that MTP interface and within the cabling, break that 1 MTP down into 4 LC duplex. And so you could have 40 gig optics on one side of your system and 10 gig optics on the other side of the system. And it turned out this was how you could solve the 10 gig density issue. You could get huge amounts of density by deploying parallel ports and operating them like they're 10 gig, operating them like they're a slower speed. And it became extremely popular. We heard, 70% of the optics that were being deployed as parallel were being broken out. And then we heard, you hear anywhere from 50 to 70%. So we tried to understand the math of why that works. So pretty interesting slide, and these are actually the economics are gotten even more favorable at Breakout since the slide was put together. But you started looking at it, and all of a sudden there's this massive density play for parallel solutions. You could get 2 to 3x the 10 gig density per blade by using parallel ports. So the highest density 10 gig line card on the market was 48 port. So my highest density for 10 gig was 48. Well, there was 32 port and 36 port 40 gig line cards, right? Well, if I operate those line cards like I'm going to break them out, all of a sudden I have, 3x the density of 10 gig ports. So you said, that's interesting, but 40 gig optics are more expensive. Well, that's true. 40 gig optics are more expensive, but they're not more expensive than 4 10 gig optics, right? The line cards are more expensive, right? But they're not more expensive than 3 10 gig line cards. So you got to a situation where you could run these high density networks and you could use literally 1/3 of the rack space. You could compress high density 10 gig networks into 1/3 of the switching space and translate that to 1/3 of the rack space, right? But it wasn't just that savings, right? Now all of a sudden there was a power savings because 40 gig ports were more effective in terms of power than 410 gig ports were. And even though the optics were more expensive, they were cheaper than buying multiple 10 gig optics. So all of a sudden you had this huge math equation that said, hey, everybody should be breaking out. If you need that density, it's really cost effective. But what was really interesting, the whole thing, is he said, what's also interesting about breaking out, some customers told us this, is for the first time, I have a migration path on my optics. I can basically migrate from a 10 gig network to a 40 gig network, and I can reuse all those 40 gig optics, right? So I have the massive day two savings of using my ability to reuse the optics, right? All this math and the pricing's just starting to roll in. All this repeats for 25 and 100 gig, right? Which is why Fibre channel and Ethernet both continue. Every new iteration of a standard includes a version of breaking it back out, right? Every parallel option has the option to break back out to a slower speed, and it's for these reasons right here. Then we tried to understand, okay, I think I get all this, but what about 8 versus 12 and a lot of on the roadmap versus transmission, right? Because at the time we set out to do this, we said, what about 16? What about 24? What about 32? And then we kind of put together some graphs to say, what's most effective across all the speeds? And what's most effective and more importantly on the speeds that win long term? So when we started graphing it out, it showed 8 having a really nice advantage over 12, 24, or 32. And, there was that one red at 20, which, as we talked about earlier, was really just a speed bump along the way. So when you looked long term, what you really got to was the widely deployed solution for 10 gig, 40 gig, 100 gig, 400 gig, a Base-8 solution, since everything ended up at either increments of 2 fibers or 8 fibers, was an extremely cost-effective way. And for the first time, we're going to match the cabling infrastructure to the transceiver roadmap, right? So people says, well, why didn't you do this a long time ago? Why was Base-12 deployed for so long? Well, the real answer is when the MTP was developed, it was never developed to be a transceiver interface. It was a backbone cabling connector, right? And a lot of the cabling was done in units of 12. When the transceiver guys found a need for a parallel interface, the solution on the market that was extremely high performing, that was cost reduced, that was available from everybody was MTP. So they just put that 12 fiber MTP into their 8 fiber transceiver, right? And at that point, if you're reusing your infrastructure, had 2 choices. You can throw away 4 fibers in every link and not access them, or you could take modules that would take 12 fiber MTPs, convert them to 8 fiber MTPs. Now you have more cost and more attenuation, but you could optimize, 100% of fibers. And a lot of companies, Corning included, released that as an interim solution. We released conversion modules to basically bridge the gap between the infrastructure and what the transceivers were and the end users were calling for. When we went back and looked at this, we really said, hey, if we're going to redo this, this is the perfect time to switch the infrastructure to match the transceiver roadmap, both for today's installations and for all the installations we can see out, we have visibility out from into the future. And that's sort of the whole analysis that went into us releasing 8 fiber solutions. Widely available on the market today. They were released last year, widely deployed. So, people doing greenfield installations and people doing extensions of brownfield really see the value in the solutions. And we've done a lot of cost modeling with a lot of our different customers. And at the end of the day, they really start to understand it. And the other thing that's really interesting about this solution you're giving a choice. It's really causing the infrastructure team and the network team to talk. And the infrastructure team, when they're really understanding what the network team is doing and the fact that they are doing breakouts and the fact that, 8 fiber transceivers are what they're buying, the story becomes even more compelling, both to the infrastructure team and to the network team. So with that, will be the last slide. I'll turn it back over to Carl, who will run the Q&A.
Dave, thank you very much. This has been an awesome presentation. I wanted to remind everybody that in a little bit you'll be able to click that button on your screen at the bottom that looks like a blue ribbon, and you'll be able to download your Bixby certificate. But in the meantime, there's been several questions that came in, and I wanted to make sure we went through this Q&A. First thing I wanted to remind everybody is that a copy of this presentation in PDF format will be made available to you on the G2 Talk archive at graybar.com. So if you go up there and look for the title of this presentation on this day, Why Base-8, you'll see that. You'll click on it, and there'll be an opportunity there for you to download this presentation if you would like it. There's a couple questions that have come in, Dave, and I have several of my own, but let's just start with this one that came in. James asked this question about the term SR, and so his question was this: does SR equal short range? And by that, in parentheses, he put 850 nanometer VCSEL. So could you talk a little bit about the term SR and short range and what that really means?
Yeah, so James is exactly correct. SR is short range, so typically 850. LR typically meant long range, which was 1300, and then you used to see like E's or something for extra long range, which was typically a 1550 wavelength. And it's important to note that to James's question is a great one, because even some of like the WDM solutions for multimode on the market. So when BiDi first came out, the immediate response, the competitive 2-fiber response to it, was WDM over multimode, but it was what they called a universal optic. So it was actually what I would call an LR4 optic. It was a wave division multiplexing, but around 1300 meter range. Now what you're starting to see is people are going back and they're doing, people call SWDM. Now they're doing wave division multiplexing, but back at the 850 range. So 30 nanometer spacing based around 850 VCSEL. So 850 or 840, 850, and then you go up 30 nanometers each time. And so it's important to know, because that indication can tell you what wavelength your transceivers are running at.
Okay, great. And on that same thread, Jim asked this question. He asked, now that non-Cisco labeled 40G BiDi transceivers are available and the costs much less than the Cisco branded, does the economics of 8 fiber parallel still the less expensive interconnect method? You mentioned all of this in the bar charts that you just showed recently, but what about this non-Cisco labeled 40G BiDi transceivers available, and has that been calculated into your economic charts, and how does that leave it? If you want to see this question yourself, Dave, you can look on the chat box.
So it's actually a really good question, because we follow transceiver pricing, right? We get it every 2 to 3 months. We update transceiver pricing. And there are some, light counting people that also sell reports on transceiver pricing. And one thing you've noticed is the cost curve for 40 gig has been extremely steep. They have been cost reduced really quick. And some of that's driven by these hyperscale guys. You have really big guys buying huge amounts of transceivers, and they're coming down the cost curve quicker. So the interesting story about BiDi, right? So Cisco worked with a transceiver partner to develop it, and it was differentiated on the market, and it was a 2-fiber solution that was very effective at delivering 40 gig over multimode. So reuse your existing infrastructure, reuse the optic. Well, you know, when you do something like that, you put the rest of the industry on notice. And so what did the other companies start doing? They said, we need to have a competitive response that runs over 2 fibers on multimode. And you essentially got this universal optic, and now you're seeing the release of what we would call SWDM transceivers, so wave division multiplexing around 850. So at that point in time, you know, Cisco had a choice. Do I stay on this island by myself when everyone else does this 2-fiber solution over multimode, so very similar value prop to mine? If all the other industry goes in this direction, do I do this? Or do I say, open up BiDi to the entire market, and then, you know, have 2 open source solutions to service the market? And that's what they chose. And as a result, it has driven some of the pricing down. Now, and this is why I always caution people about transceiver pricing. Every model you do looks completely different based on the cost you pay for transceivers. So we do this with our customers all the time, where we have our pricing loaded and we send them models and we say, input your transceiver pricing. Because not only are people paying wildly different prices for transceivers, people are procuring them in different ways, right? Some people are buying them from the switch manufacturers. Some people are buying them from the transceiver manufacturers and doing other things, and it very much changes the math. So what I would say is, if people do have questions about that, you know, reach out, you know, through Graybar, and they can get in touch with someone at Corning, and we'd be happy to do an individual cost model that's customized to the price you're paying for the different components in your data center.
That's great, and thanks for that information, because Robert did ask a similar question about cost when it comes to why the red triangles in the presentation for base 24 in cabling system. And if we can customize a cost model for Robert, we'd be happy to put that together for him. So Robert, depending on your particular circumstance, if you'll get in touch with me, carl.griffith@graybar.com, I'd be happy to get you in touch with the right people that can help you with that. And by the same token, Nalinda also asked this question: is it possible to get another presentation done in person for her team? And the answer to that is yes. And so I'll tell Nalinda the same thing. If you'll contact me via email, Carl, Karl, Griffith, Griffith, @graybar.com. We'll arrange for that presentation for your team, Nalinda, so they can get this information as well. And remember, Nalinda, you can always go up to the graybar.com archive, just look for the G2 Talk logo, and you can get this presentation represented in its same format. It's been recorded, or you can download the presentation. I wanted to make one more offer to everybody that's on the line. We have a white paper available for you that describes parallel optics, and it might be very helpful to you from a design consideration. It's quite extensive, and it has a tremendous amount of information available. If you'll just go to the Q&A dialog box right now and just type in the letters WP. If you just put the letters WP in the dialog box, at the Q&A box at the bottom of your screen, if you'll click that and type in WP, we'll make sure that you get this this white paper sent to you and given to you. The other thing I wanted to bring up is just a couple things, and these are my questions while people are responding to that offer with the WP for the white paper, Dave, is I'm taking from your presentation that the path to 25 and 50G, and we've been talking about that a little bit, it may be diminished a little bit. Can you give us a little more information about this Base-8 versus 25 and 50G. Is this just going to be circumvented by 40 and 100? Is it going away? Is 25 and 50G a copper thing and not a fiber thing? Can you just give us a little insight there about what's going to happen when we hear a little look in the crystal ball about what's going to happen to 25G and 50G?
So no, it's not a copper thing. And actually, if you look at the adoption curves, you actually see 50 gig overtaking 40 gig. So you basically see 10 gig getting replaced by 25 gig and 40 gig getting replaced by 100 gig as the need for speed increases. Still over multi-mode and single-mode fiber. You know, the distances of copper start getting, you know, obviously shorter and shorter and shorter to, you know, at 25 and 100. We'll see how it plays out, but it's probably a within-the-rack solution only. So it actually pushes fiber further out into a lot of networks. So the people that need speed, so if you talk to most of the hyperscale guys and if you pay attention to all the press releases that come out around OFC next week, you know, I know this because we've been testing all the transceivers for a long time. You're going to hear a lot of talk about everything they're going to be talking about is 25 gig, 4 by 25 100 gig, or 4 by 25 WDM, and 400 gig, right? That's what you're going to hear about. So I think the opposite will happen. I think if we had this webinar in 3 or 4 years, especially if I'm looking in the hyperscale space, 10 and 40 gig will be a lot of a thing in the past, and almost all of those big guys will have switched to 25 gig and 100 gig.
All right, great. Well, we're at our hour, Dave, and I want to thank you for answering my question about 25 and 50 gig, and also thank you very much for answering the questions that came in on the via the dialog box. So we're about ready to wrap up here. I want to thank everybody for attending. Remember to hit the blue ribbon to get your BIXI certificate. Also remember that you can that these presentations have been archived. You can always go back to graybar.com and get them. And I want to thank Dave. Well, what a wonderful presentation. Terrific information to help us in our industry, and we're so thankful to have you with us today. Thank you, everyone, for your time, and we're looking forward to the next G2 Talk webinar where you can join us. Have a great day.